Hi everybody, I'm Bárbara Pedo and I'm currently a master's student in Brazil at Federal University of Rio Grande do Sul, and I'm also a research assistant at the Innovative Design Lab Research Center at the University of Huddersfield, UK. The authors of the paper are also Fernanda Brandalise, Daniela Viana, Patrícia Tzortzopoulos, Carlos Formoso, and Andrew Whitelock. The presentation will be divided into 5 main sections, starting with the introduction. The background is related to the limitations of traditional approach of communication and design, and also related to the need to improve the way that information is managed. Considering that, the research is exploring the visual management strategies to support the management and control of information. However, the links between VM and information technology has been poorly explored in the literature, and there are few studies exploring the implementation of VM in design. The aim of the paper is to explore benefits and barriers of digital VM tools in design. It describes digital VM solutions adopted in the design management process of 2 infrastructure projects, focusing on design, planning, control, and coordination. Talking briefly about the literature that is supporting the analysis, it is considering the taxonomy of advanced practice of VM systems proposed by Brandalise 2018. There are 3 categories of communication and integration, which are one-to-one, one-to-many or many-to-one, and many-to-many. The taxonomy enables understanding of how information is shared between users, that is, in which way communication occurs between information senders and receivers, and how much the VM practice is really integrated to the management routines. The paper is also exploring VM concepts identified in the literature, and this investigation is analyzing them related to digital visual tools in design management contexts. So, the concepts are simplicity, information standardization, autonomy to plan and control, right amount of information available, easy accessibility of information, flexibility, and information traceability. The research strategy adopted was design science research. The study is divided into 3 phases. The first phase includes an understanding of the problem, looking at the company's design process and VM tools. The second phase is based on an understanding of issues and identification of VM benefits and barriers. And the last phase is the analysis and reflection on the integration of VM tools with design. The main sources of evidence were open and semi-structured interviews with design team members, project directors, and managers, for example, direct observations of project meetings, analysis of VM tools interfaces, and workshops with key project members. The empirical study was carried out in an infrastructure design company from the UK, which develops design, consultancy, engineering, and project management services. 2 projects were analyzed in this investigation, considering highways and railways construction projects. The company has a complex structure with a wide range of internal and external stakeholders. The results are divided into analysis of the VM tools and discussion. Different types of meetings are carried out regularly, some for design planning and control and others for coordination. The management process includes different hierarchical levels of meetings, which are master planning, phase scheduling, monthly meetings, weekly meetings, and daily meetings. The VM tools were used to support the design, planning, control, and coordination at tactical and operational levels mainly, which are the monthly and weekly meetings. The first to analyze was the activity tracker. The aim of the tool is to assist in the control of activities by design discipline and update the tasks and actions during the weekly meetings. The discussion is focused on planned dates as well as the identification of reasons for overdue tasks. All the team members have access to the digital tool all the time through diverse devices and displays. During the meetings, the tool is displayed on the project manager's screen, enabling information to be shared with everyone. The Performance Dashboard is a digital visual tool used in monthly meetings to display planning and control performance metrics. The data used to create the performance metrics comes from information collected through the activities tracker. It mainly helps project managers and directors in analyzing the team progress through weekly PPC and reasons for non-completion of work packets. The clash detection and visualization tool is used in weekly design coordination meetings. This tool is used to create beam-federated model, identify clashes between disciplines, visualize combined models, and help to assure the quality process between disciplines. The combined model is adopted as a visualization tool and drives the design decisions during the weekly meeting. So, considering those VM tools, the VM concepts, and the taxonomy presented before, the following analyses were done. The Activities Tracker tool can be classified as a tool that adopts most of the VM concepts. By contrast, the other tools lack the application of some VM concepts, such as autonomy, information availability, information accessibility, for example. This chart illustrates clearly this relation between the VM tools and concepts. For example, we can see the substantial adoption of VM concepts by the Activity Tracker tool, which is supporting a greater integration of the tool into the design management process. Exploring the taxonomy, it's possible to identify that digital VM tools usually involve more users than traditional VM tools, and the transfer of information between stakeholders can be classified as one-to-many, many-to-one, and many-to-many. The Activities Tracker is classified as the tool that adopts most of the VM concepts, as I mentioned before, and also the tool which should be used by a large number of people because it is classified as many-to-many. The benefits will be described in this tool, even the other ones presented some VM concepts adopted as well. The benefits can be related to information availability, accessibility, and autonomy. The easy access, understand, and update to appropriate and accurate information by distributed teams can result in an increased team productivity, for example. The ability to track design decisions and changes through a systematic approach during the design enables efficient communication and faster feedback. And the increase of information decentralization allows independent use of the tools by all stakeholders and also encourages the reduction of design management time. The performance dashboard is the less integrated tool to the management process, considering it is created with team members input information, but only the project manager uses it in an effective way, considering that it is classified as many-to-one. Some barriers are related to it's not easy to access. There is no clarity about how to use the tool and where to find information, as the tool is based in a cloud system and users have no knowledge and skills in tracking the tool. It presents a lack of availability, a real-time availability. Some specific metrics from the tool are sent in reports to the team members as a static information, and it presents a lack of decentralization, considering that there is a need to decentralize the use of the tool, enabling them to have more responsibility to control and evaluate their own activities. The clash detection and visualization tool is used by different stakeholders and disciplines through the process. However, the information transfer is not fully integrated, as the information is partially accessible and available due to the fact that the right amount of information is not available when needed during the design process, and also there are challenges related to the regular sharing of information. And the simplicity and flexibility concepts are not adopted, presenting an amount of information inside of the tool and creating issues to prioritize, select, and update it. So, some final comments about the results. Visual management strategies were identified in design process through the use of digital tools. The proposed classification of VM tools explored the potential benefits and barriers of each tool investigated. It helps to better understand how effective VM tools are by analyzing relevant VM concepts and investigating the integration with stakeholders. The main benefit is related to the potential to integrate many stakeholders as they involve many users and disciplines in different ways of communication, and the main barrier is described as the lack of traditional VM concepts in digital tools, such as simplicity and flexibility, affecting its efficiency in use. This research is limited to the study of 3 tools, so further work should explore a substantial number of digital VM tools, enabling further exploration of the barriers, identifying how the design process can be further improved through the adoption of digital VM tools, and further investigation of improvement opportunities, exploring how to improve the tools and simplify accessibility and availability issues, for example. Thank you very much. You have my contact details here, so please feel free to be in touch with any comments or questions.